this is the monkeys typing Hamlet question that Richard Dawkins, and he took in there a phrase out of Hamlet. Methinks it is like a weasel, taking the 28 letters in this sentence, and then he's going to run it and see how long it would take to come up with methinks it is like a weasel, and he's replacing each letter randomly and then using a selection algorithm that will look at the target that you're after, which is methinks it is like a weasel, and if the two match, he'll freeze it. He'll freeze that letter. Now, how long does it take?
Welcome to the Creation Today show, where we bring together interviews with experts and solid Bible teaching. Your host, Eric Hovind, affirms the ultimate authority of God's Word, the truth of creation, and why it matters to you.
So if 1 million monkeys were typing randomly on 1 million keyboards, could they ever type a line from one of Shakespeare's plays? To be or not to be? That is our question for today. Evolutionists have made the claim that life evolves much the same way as monkeys typing randomly on keyboards. Organisms randomly change and make up new forms of life over time. Well, today we're going to put that theory to the test. You see, with modern computer simulation, we can actually simulate random keystrokes and find out exactly how long it would take to get a single line from one of Shakespeare's plays. Now, this is much like what the evolutionists teach, who say that the amino acids, which are the building blocks of life, kind of like the letters in an alphabet, randomly organize themselves into the first living cells. So, let the games begin, shall we? Does evolutionists claim that new species will form by random mutations over time? Does it really stand as a scientific chance? My guest today holds his Bachelor of Science in Electrical Engineering from the University of Wisconsin. During his 40-year computer design engineering career, he was actually a member of the team that designed the Star 100. It was at one time in the Guinness Book of World Records as the most powerful computer. He lived in Israel for 4 years. He worked at an Israeli computer manufacturing company. And he has been, he accepted Christ in 1978, which was the year I was born. So that was 46 years ago. That was when he was 30, which means he's 3 decades older than me. He and his wife, Mary, they live in both Pennsylvania and in Texas. They have been foster parents or group home parents of more than 40 troubled teens. So they got a lot of kids and grandkids now, really. It's kind of fun. It is Mr. Jim Hoff. Jim, thank you so much for joining me today. I appreciate you coming on the show.
My pleasure. It's a pleasure to be here. I'm excited.
I have thoroughly enjoyed getting to know you over the years. And when I was at the solar eclipse just a couple months ago, you gave a talk that made my mind explode. And I went, oh my goodness, you've actually written computer code to simulate what the evolutionists say could have happened to create life. And you literally right in front of us put it to the test, and it was brilliant. It was absolutely amazing. Tell me about your background and what made you think of that, and like what made you say I'm young Earth, I'm gonna agree with the Bible. Like, give me the short version of that real quick.
Well, things having to do with probability have been part of my career all along. I have 4 patents, and one of them is on a probabilistic way called a stochastic way of calibrating a timing instrument that measures time down to picoseconds. So that was, natural part of my background to check this thing out.
So your mind already works that way. That's how your training is done. Your career has been involved in this. And you were familiar with Richard Dawkins in his book, The Blind Watchmaker. He said, he didn't know who pointed out, but he's like, given enough time, a monkey bashing away randomly at a typewriter could produce all the works of Shakespeare. That's what he tried to say.
That's what he said. And then he puts a caveat in there, of course. The question is how much time. So we'll take a look and see if we can get a Shakespearean sonnet out of this computer.
Oh, I can't wait. This is going to be good. This is going to be good. Well, tell us where we should get started, because I know probabilities and stuff, that's kind of, it's kind of hard to grasp. So like, take us on a journey here to understand this.
Okay, well, the first thing, everyone, I would like to start off by saying that we take chances all the time. You have to decide, are you going to drive to across town? Are you going to get hit by a meteorite on your drive across town? Well, you know that that's a very low chance. More likely, you're going to get hit by another car or something like that. But you have to take probabilities and chances into account all the time. Well, we have a deck of cards that we're all familiar with. A deck of cards. I got a deck of 52 here, and we people play solitaire on this. You think about right now, there's probably people, night watchmen somewhere around the world, who are sitting there bored, and so they got their computer open and they're playing solitaire on their computer, something like that. So when the computer randomizes the cards, shuffles the cards, what kind of probabilities does that produce? Well, I've got a machine here that I've got off Amazon. That will shuffle a deck of cards, and I'll try and do it angly here so you can see it work. But let me see here.
Oh yeah, yeah, it shovels them right up.
Yeah, it does it, much faster. I can't do that. That's the way this shuffler works. But when we've done it, I've shuffled them here probably half a dozen times already. So they're pretty random. The question is, how likely would it be that that you would find some particular ordering? Because here's what scientists say. They say that you can put together these amino acids randomly in a soup, in water, and they will just by chance come up with some pattern that springs to life. Well, what if the deck of cards here, what if there was an ordering of these deck of cards called a permutation that would spring to life? Would we have ever found it? That's a question. I think most people, yeah. In fact, I went to a presentation one time back about 10 years ago, where it was a bunch of evolutionists celebrating a victory in a Pennsylvania court case, and he was making his victory laps. So he wanted to go and kind of poke his finger in the eye of Michael Behe, who was at Lehigh University. So I found out about it, was able to go to that lecture, and when I did, I sat down with some people. It was a party atmosphere. Everybody was really excited because they won the lawsuit. And so I asked one of the guys there the same question about the cards. If there was a combination of a deck of cards, would it have been found? And he gives me this blank look and says, I said, "That's what would be the probability that it would be found?" He gives me a blank look and says, 1, which means absolutely would have been found. 1 is certainly would have been found. 0 is it would not be found. A half is 50-50 chance, that kind of thing. And so, this is the way we think. We think that very unlikely things, I'm going to show you that it's unlikely. We think that unlikely things like this can happen all the time. So what I want to do is first of all, we'll talk about a deck of cards, and then after that, we'll do the monkeys typing a program, okay? So here,
nice, I love it. And when you say deck of cards, you're saying, just like amino acids, there's like 20 amino acids, and they all have to be in a certain order in order to get life. Like in that order, boom, you've got life. You're going, okay, what are the chances of getting cards to be in a specific order? If there was a ace of hearts, and then the 2 of spades, and then this, and then this, and there was a certain order, and all of a sudden the cards would come to life, what are the chances that we'd actually get that order?
Yeah, by chance.
Okay.
Would we have found that? In other words, do we know that there is no ordering of a deck of cards that would spring to life? Have we found all of them? Has it ever happened so that we would know that it happened? And we'll find that out here, okay?
Oh, I like it. This is cool. Okay. Sliding down Mount Improbable. Okay, you're kind of telling your hand with your title there what you think about this. Okay, this is good.
Well, of course, Richard Dawkins wrote a book, Climbing Mount Improbable, and he was giving away his hand when he wrote that. So this is a play on that. Okay, so
love it.
All right. Let's go on here. Let's do that thought experiment. This is what we were talking about. What if you were to take 1 trillion people? Now, 1 trillion people is more than that have existed on the earth at all time by anybody's count. Young Earth, creationists, old Earth, evolutionists, all of them would say that it's been less than, say, 100 billion people. This is 1 trillion, 10 times that, okay? So if we're to take a trillion people, and then give each one 1 trillion computers. Now we're going into la la land, okay? because we don't have that. But trillion. Most people are familiar with a trillion because $1 trillion of debt. That is a huge amount. But anyway, okay, every person gets a trillion computers, and then we let each one of those computers shuffle a deck of cards at a rate of 1 trillion shuffles per second. That's not a microsecond, not a millisecond, not a microsecond, not a nanosecond, but a picosecond. Light goes about maybe a 10,000th of an inch in a picosecond, but when it goes around the world 7 times in a second. So that's really, really, really fast. Okay, so now we've got 1 trillion, trillion, trillion shuffles per second. Now, how long do we want to do that? Let's do it for 1 trillion years. All right.
Why not?
So
Stick with it.
now we've got 1 trillion, 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 and then you got a multiplication that goes there because you're going from seconds to years. And so what would happen? The answer is, would you ever encounter every ordering of the cards? And the answer is no. Under these conditions, your chances of encountering any specific permutation or ordering of the deck of cards is 1 in 1 trillion. So even with all those trillions in there, your chances are still 1 in 1 trillion. In other words, you'll never encounter it. It would be perverse. It would be obtuse to assume such a thing. Okay?
So you're saying 1 trillion people, each one has 1 trillion computers, and each computer is going to shuffle a deck of cards 1 trillion times a second, and we're going to do that for 1 trillion years. Would we ever get like the same or the exact ordering of cards? Like, okay, you got to go through that, because that's like, you're just saying no, we wouldn't.
Maybe there's some magical ordering of the deck of cards that would make it come to life. Now that's kind of like what scientists are saying with the amino acids. There's a magical ordering of the amino acids that, if we get it, would cause this protein or proteins to spring to life. So the question is, with a deck of cards, would we have ever found it in all of history? Now, of course, I'm taking everything to the extreme here, and the answer is no. And let me just, on the next slide, I can show you why that is. Okay, the number of permutations of a deck of cards. Now, if you have a calculator on your phone, maybe some of the nerds like me have already found this, but there's one key on your phone that's got an exclamation point on it. And some of you might not know what that is. That's called the factorial. And what that's doing is that is telling you what happens for a 52 factorial. The number of deck cards there are is 52 times 51 times 50 times 49 times 48, all the way down to times 1. Of course, it does nothing, that one. But and that's how many combinations there are of a deck of cards. Because if you think of it, take a deck of cards, all 52 of them, throw them in a bag, and then take out one card at a time. Your first one, the chances of getting whatever it is you want to get is 1 in 52. Get the second one is chances of 1 in 51. So the chance of getting both of them is 52 times 51. Next one's 50 and 49 and 48. So that's what that factorial button is on your scientific calculator on your phone or whatever. Okay? So that's what it is. 8 times 10 to the 67th power. That is a huge number. So here, let's look at this. Okay, there's 80.
Yes, I just did it. I didn't know what the exclamation mark was. I just did it. Wow.
So you put in 52 and hit the exclamation point?
Yes, 8.0658171 E67 to the 67th power. Wow.
There you go. Okay, so that's for real. All right, so now we're going to go through here. This is kind of just a fun exercise. Wikipedia will give you the names of all the numbers, of all the larger numbers. Here we got 1,000. There's 1,000,000, 1 billion, trillion, quadrillion, quintillion, sextillion, septillion, octillion, nonillion, decillion. Okay,
yes.
You see the pattern there. Now you got to add something on it to get the one from there. Undecillion, which is 1 in 10, okay? Duodecillion, tredecillion, quadridecillion, quindecillion, sexdecillion, septicillion, octodecillion, novemdecillion, vigintillion, and that's as far as they go, which is 10 to the...
That's the biggest number?
Well,
I know it goes past that, but that we've labeled? That we've named?
That's the biggest one we've got a name for, yeah. That's it. Now, that doesn't handle the deck of cards. You need another 3 zeros in order to get that. So here is... That is the number of permutations. That's an 8 with 67 zeros after it. Okay.
That's how many different ways that those 52 cards could be ordered.
Right. Right. And that's, the word for that is permutations, not combinations, but permutations. But that's an ordering that's what that is. Okay. So let's just look at a little bit here. Do a quick calculation. You got the trillion people, a trillion computers, a trillion shuffles, just as we said before. Now it turns out that the number of seconds in a year is about 31 million, which happens to be 10 to the 7.5 power, almost exactly, which is kind of cool. But anyhow, so then we got a trillion years. And you multiply those together, you may know, you math people, that when you want to multiply exponents, you just add the exponents. When you want to multiply exponentials, you add the exponents. So it's 12 plus 12 plus 12 plus 7.5 plus 12 gets you 10 to the 55.5 power, okay? But the number of combinations of a deck of cards is 67.9. That's that 8 times 10 to the 67. So you subtract those and you get 10 to the 12.4. That means your chances are worse than 1 in a trillion of finding that particular one. All those shuffles, which is just ridiculous. You still would not have any kind of a ghost of a chance of finding that combination that would magically come to life. Okay,
That is amazing. That means all the casinos and all the card shuffles throughout all of history, we probably still have never gotten all the different orders that are available at 10 to the 67th power.
Nothing even close. I mean, we're probably at 10 to the maybe. Well, here, let me do a more practical example here. In fact, this is one that blows me away. I didn't even realize this until I had been doing this for 10 or 15 years. You shuffle a deck of cards at a rate of 1 billion times a second, okay? And you do that continuously for 1 million years. Every single randomly shuffled permutation or ordering of those decks of cards would be a unique ordering, never duplicated before or since. Every single one of them. So if I were to take this deck of cards that I've got here, I don't know if you can see it. Can you see me on the screen or not?
Yes, when you hold them up. Yeah, when you hold them up.
Okay.
Yep.
Okay, so if I take these and I pull them off there, it's been randomly shuffled. This has never existed. What I have now has never existed in all of time. Now, if I take this and cut it, that's a new random shuffling that has never existed in all of time. Now, as long as I don't get one that I just like cutting it again in the same place, so I'll put them all in the middle like this, that's a new one that's never existed and never will exist. Every time I do that, every time you shuffle them, move the cards around a little bit like that, you have a new randomly shuffled deck of cards that's never existed before and never will again. Is that amazing or what?
It's mind blowing when you actually do the mathematics of it and you realize what those chances are. That's incredible.
Okay, now I don't want to, bore you with math because I know some people, their eyes glaze over when they see it. But if some of the people who nerds can look at this in the the replay and come back and see 10 to the 9 shuffles per second, that's 1 billion. 10 to the 7.5 seconds per year. 10 to the 6 years gives you 10 to the 22.5. That's not even the square root of 10 to the 67, which means
of the possibilities.
Yeah, you would have to get up to about 10 to the 33rd before you'd start having repeats of those. So, we're 10 to the 10th away from even having a single repeat by chance.
This is incredible. Okay.
All right. So go on. I'll just continue.
Yes. I'm like, okay, so and we're using the cards to kind of simulate the concept of amino acids because the evolution worldview says amino acids formed by chance. And then lightning struck or something happened and just happened to arrange them. They just happened to get in the right order in order to produce life because there is no author of life. There is no God that created life. It happened by accident and that happened by random chance. And so we're doing the probabilities of what are the chances. So the chances of a deck of cards, oh my goodness, you have 10 to the 67th power different mutations that could happen, if you could say that. And so the chances of getting the one that comes to life, because like proteins and the amino acid sequence, they have to be in a certain order.
That's right.
You mess one up. Yes, you mess one up and it's done. It's not life, it's death. There's a whole lot of death and very little, life possibilities.
Right. And when we get to the end of the program here, I'll talk about J. Craig Venter, and what he did. And he was just blown away by this himself, by his own experiments. Okay. So we'll show you that. But
All
okay,
right.
so that's the deck of cards. Let's go now to the monkey on the typewriter. Okay, I think this is a very humorous. This is right off of Wikipedia's Infinite Monkeys Theorem page. Okay,
Yes.
and they have a picture. And look at the title up on the top: a chimpanzee probably not writing Hamlet. and they go through the numbers to show that you can't. You just it wouldn't. It's absurd to think that. So I was very happy to see that on their website. Okay, so let's go on here. Okay, here's Stephen Hawking, and he's got a book, a brief history of time, and he is a tremendous man. I mean, he's passed away now, but he was a mind that is just amazing. And you may not know his wife was Christian. If you've seen the story of his life, but he was very angry at God for some reason, and so he really wanted to prove that God did not exist. And so in his book, A Brief History of Time, he wrote this. Now, what it says in the first part of here is part of the context of, a very complicated part of the book. So I won't go into that. But at the end of it, he summarizes it by saying, it's a bit like the well-known horde of monkeys hammering away on typewriters. Most of what they write will be garbage, but very occasionally, by pure chance, they will type out one of Shakespeare's sonnets. Okay? So he is referring to that. Now, we're trying to figure out how old this monkey and typewriter is. I looked up, the typewriter was invented in 1852, and the word was coined at that time too. So it couldn't have been older than that because we didn't have typewriters. But okay, so that's Stephen Hawking. Then, of course, we mentioned here Richard Dawkins, and that's where we're at right now, the blind watchmaker. And in chapter 3, I believe it is, he writes, this is a quote from him. I don't know who it was that first pointed this, and this is what you quoted at the beginning of the program. I don't know who it was that first pointed it out that given enough time, a monkey bashing away at random on a typewriter could produce all the works of Shakespeare. And then he goes on to qualify it. The operative phrase, of course, given enough time. Let us limit the task, and he goes on to how we could limit it. How long would it take to write this one little sentence? And then he wrote a program. Now here, we're gonna have to see if I can bring that program up for you here. It's right here. Okay, all right. This is the monkeys typing Hamlet question that Richard Dawkins he took in there a phrase out of Hamlet. Methinks it is like a weasel, and what he means by that, these people are kind of musing. They're looking up at the sky. You know how you look at the sky. Well, that looks like a pirate ship. That looks like an angry old man, and so forth. Well, one of the characters says, "Methinks it is like a weasel." And so he just pulls that out. He's very poetic and very dramatic, and so he takes this. So what he's trying to do here now is he's taking the 28 letters in this sentence, and then he's going to run it and see how long it would take to come up with "methinks it is like a weasel," and he's replacing each letter randomly and then using a selection algorithm that will look at the target that you're after, which is "methinks it is like a weasel," and if the two match, he'll freeze it. He'll freeze that letter. Now, how long does it take before he will come up with the full thing here? Okay, so I'm going to start this, and you'll see what he found. He usually found that it takes somewhere 35 to 40 characters before you find it. Now, red means it's wrong, original and wrong. Yellow means it got changed, but not to the right thing. And green means it's what we want to have. Now, this one's taking quite a bit of time. This one took 55 iterations. Okay, it's usually in 35 to 40. I'll run it one more time so you just get an idea. Watch how it goes here. See, it started out all red. Now, sometimes it'll start out green with a couple letters. You just by random, you get them correct at the first time. But we haven't seen that here. And 40 should be right around this time that it ends. Well, it's taking the same time this time too. In fact, a little longer. 63, 64. Get that one letter is just going on and on and on. But he found, there it is. At 82, it got them all. Okay, so can any in your audience tell me why this does not show what evolution could do?
I've got an idea. I'm curious what you guys think. So hey, my Creation Today partners, that I can see your chat right here. What is the problem with his thinking on writing this program? What's the problem with this code? Amanda says, because they would mess up other letters eventually. How would a cell know what is correct? Jonathan asked that. And then James said that's not completely random.
Okay, that's right. And all those well, let me tell you what normally would be said about it is that he had a target. His target was methinks
Yes.
that it's like a weasel. Evolution doesn't have a target by his own admission. And in the Infinite Monkeys Theorem article, he talks about Dawkins doing this, and he's very forgiving. He says, he put this in the book, but he didn't mean for this to be an explanation for how, like, the name of the book is The Blind Watchmaker.
That's the
Why
whole
put something in
point.
there? That's what that's what the purpose of this was. Well, what it is here, just for people to understand this, what happens is when you're in this medium of evolution, you lose your critical thinking. You no longer think about what it really is, because you know that this is what happened. Evolution happened, and so
Mm.
you're not critical and checking it out. So he put this in there really stupidly. I'm not saying he's a stupid person. He's a
Right.
doctor. He's at Oxford. He's a fantastic. Nor is Stephen Hawking. But they lose it when they're trying to find the chances of something, because they know it happened. They're just trying to find out how it happened that they know it
Right.
happened. So
Joe,
that's what
my
happened here.
mom Joe put an interesting thought. She said, plus all those other iterations are all death. And you're not accounting for nothing survived, nothing survived, nothing survived, nothing survived, nothing survived, nothing survived, nothing, something lived. I mean, it's like, wow, that's a great point.
That's right. And that's the same thing here too. And we have the same problem when you're trying to mutate a new protein, for example. There is a guy at ICR, I'm trying to think of his name now, Axel Axe. You know what I'm talking about? Axe is his last name. He did
Dr.
a
Douglas Axe?
That's right, Douglas
Okay,
Axe.
he's with
And
Discovery Center, not at ICR, Discovery Center.
Okay, thank you for correcting me. And he found that the chances of coming up with a novel protein from something that already exists is 1 in 10 to the, it's around 10 to the 80th, 10 to 76, I believe was the number. And you already know what these big numbers mean. 10 to the 80th is the number of particles in the universe, number of atoms in the universe. So and in between these is dead space. You can't iterate your way, because everything in between is junk. So it would not be saved. This is a problem all the way through the evolutionary story.
Wow.
Okay. So now let's go to what we had planned before with the monkeys. I'll give a little bit of an explanation beforehand. What we're going to be seeing here is a single monkey typing on a typewriter, and he's going to be typing random characters, and he's going to try to type out "me thinks it is like a weasel," but he's going to do it randomly. And in order to do so, he's going to type. He's going to go peck 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 peck, and he'll maybe once every. It's a keyboard with 31 keys. So you have the 26 letters and a comma and a period and so forth. And when he types an M, it'll stop the program, and it'll do the ta-da sound, ta-da, and it will show you that he got the M. Then from that point on, it will switch to now it'll try to find ME in methinks the ME. And so it will type, now it's got to go 31 times as long in order to get that, because it's got to type the M 31 times before it happens to randomly get an E after it. And when it does, it'll go ta-da, and then it goes to MET, which is 31 times longer than that, and so forth. Okay?
Okay.
All right.
And
so
is this
now?
This
I
is
think
the
we've got
video
it up
that
here,
we
right?
okay. So yeah, this is the program that you're running right now. Okay.
All right. So should we make that full screen? Can I make it
I
full
can't
screen?
make it full screen unless I share screen, so I can't do that. I'll have to. I'll leave it there, and people can see it right there. They're able to see that.
All right. Well, if you can see here, in this little box, we've got "me thinks it is like a weasel." Okay, you heard that ta-da sound. We got the first. We got the first letter. We got an M, and now it's stopped. And while it's stopped, let me just explain here. In this gray box, we have on the top line, "me thinks it is like a weasel," the target phrase. Okay. The second line is telling you how fast we're typing. It says 1 per second. Third line is that's I'm having a hard time reading it there.
Oh, sorry. Hey, if you go up to your view, you can hit speaker, and then you may be able to see that better, or double click that one in yours, and you can see it better. I'm not sure.
Okay, let me see. Now I don't see it happening, and that's okay. But okay, the third line is telling you how many characters per second are being typed. Now we've gone up to, I believe it's yeah, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Every 10 seconds, it's going to double. Okay. And you can see the M's are being typed. That means that we got the first letter, but the E will eventually get typed, and then it'll switch over to
Okay.
faster. Okay.
Okay.
So we can just kind of watch it. We're going up and fast. Now I think we're going up to 16 characters per second. Sorry that the sound is so obnoxious, but you have to hear it in order to realize how fast this monkey is typing. Each tick is one of the typewriter being one key being pressed. Okay, we don't have the sound. At least I don't have the sound.
All right. If we're quiet, it should come on.
Okay, well, what are we at? 30, going up to 64 now.
And we're trying to get is ME right now. We're trying to get.
Okay,
Oh, got it.
We just got it. Okay, we got the ME. If there is some problem with the sound, you might want to, Amanda or someone check it and see if there's a way to get the sound back.
Okay.
But okay, so now just that's so we can see the ME. Now, as I said, we're switching over to looking for MET. So you'll see ME come up, but it won't stop. Oh, there we go. Okay, now we're looking for the MET. You see the. Now I want to show you something here. This is a spectrum analyzer. It works the way your ear does, amazingly, but it's showing you. You'll see as we get up there, it will show you that tone coming up on the spectrum analyzer. What are we at? 500. Can you see that peak?
Yes.
For example, I can whistle and make that peak. See that? Okay, we're now at 1,000. Okay, let's keep going. There's 2,000. Now, a strange thing here, we're going to go to 4,000 keys. The monkey still isn't getting that fourth letter.
Oh,
It got
yay!
it.
We got
Okay,
it.
it got it. It got it. Okay, now when it starts up again, watch. It'll be. I think it's going to be at 8,000. And you young people you'll be able to hear a sound above 8,000. But us older people like myself, my hearing cuts out at about 10,000 hertz. But
Wow.
my cell phone is not connected to the computer. It's actually listening to the computer. Okay, there you see that peak again.
Yep.
There's 8,000. And my ears are beginning to cancel out.
Yeah. I lost it. I can't hear it now either.
Okay, so that's just some interesting side note for the geeks among us. But so okay,
So
now so I'm going to put on top of this now a second program. This is going to keep running. I'm going to take that gray box and put it down in the bottom corner and bring up another program because. A skeptic is going to say, well, that's one monkey. I mean, we're talking billions of monkeys. Well, what happens when billions of monkeys are typing and they're typing really fast over millions of years? Are we going to get it? So I wrote a second program, and in a minute, you'll see this program will drop down to the bottom. That box will drop down, and then we'll bring up another one here.
And so right now, before you switch over to the other one, about how fast are we going? This is one monkey typing how many keys per second?
Well, he's typing 100,000 keys per second.
So we're at 100,000 keys per second. Oh, and we got it. We got it. Okay, we just got.
You got that. We got METH. I think that's.
So that was to get 4 letters in a row. That was to get METH. Right.
So now he's going to work on 5. Okay. 30 times 30 times 30 times 30 is about 1 million. So you should have typed about 1 million characters. Now it has to type 30 million to get that 5th letter, and then 1 billion to get the 6th letter. Okay, you see how that works? Now when he's doing 100,000 characters a second, he's able to type out a typical novel in about 5 seconds. There's about 500,000 characters, so he's typing out a novel every 5 seconds. Novel's worth of characters. Okay.
So. Really what we're getting, okay, here, you're going to do the other program now, okay. But we're getting a whole lot of junk to try to find this methinks, okay, METH.
Right. And since we pre-recorded it, I can tell you that this is not going to find the fifth letter in this run, but that's just a random thing. Okay. So here now
Wow.
I'm bringing up this second program, and got to go find it here. There it is. And okay, we'll get rid of the. There we go. File manager. Now this program, you can see it's got just characters in green and then seconds in yellow. That's how many characters it can type. It's typing, and the seconds is how much elapsed time has gone by. The first thing I'll do is just type 4 characters a second, just to give you an idea of how that would go. Okay, so should do it in just a second here. It'll click on that on the bottom. It's got a type 4 characters per second button. Let's see.
Okay, so
Oh,
we're at 0. Okay,
yeah,
you're about to start it. Okay. All right, so characters and then how many seconds? And this is going to let us simulate multiple monkeys. Is that what this is going to let us do? If it's not just one monkey, but it's multiple?
Right, multiple
Okay,
monkeys.
there we go.
It'll also let us scale the time, so we can look at tens of years going by, hundreds of years, thousands of years, whatever we want, per second. So you can see that you can quickly type out Genesis 1, 1, and 2, and when you're typing 4 characters a second. But and see, we're at 73. Okay, so now we're going to stop it, and we're going to type out. We're going to just let the monkey typing random characters. And like you see on the other program, which is running, screaming along behind it, and not finding that fifth character it's looking for. We're starting to carry right here now. Now in this one's done mathematically, so we can actually figure out percentages or fractions of a second of a character. Okay, so right now we're up at 16, 17, 18 seconds. It has to get to 31 seconds before it prints out first character. So we're at 22, 23, 24, and you can see it's going 0.93, 0.94, 95, 96, 97, 98, 99. Boom, we got an I. We got the I in the beginning. Okay, that's that first character. Now, I know your program isn't long enough for us to keep going for second and third and fourth characters here. So we'll have to do something a little different. And what we'll do is we'll now make it more monkeys. Okay. So down on the bottom, I'll be picking, I think I pick a million monkeys to start with, just to give you an idea. Okay. Now, how many characters do you think that a million monkeys will type each second? I think people tend to think, wow, they type a lot. But you'll find that no, they will type. I think they would type 6. I think there's 6 characters. Okay. Well, there you see it. I guess I'm wrong. It's 3 characters so far. But working on the third. Okay. It can't type. It can't pick up much of anything. Boy, I wish we could get that full screen so we could.
In the edit, I'll have it full screen so everybody can see it.
So in the edit, we'll be able to do that.
If you need to see it better, go up to the top right where it says View in your on Zoom. It says View, and click Speaker, and then I'll come up big. Click Speaker, and then the one that has the video playing, double click that on that top bar. Double click that, and that'll go full screen.
There we go. Yeah. Okay, now I can tell you a little more exactly what's going on here. Okay, so now we're in that time we've been doing it. We've gone up to 10 to the 80th, 10 to the 90th. Now it's 1 Google. Okay, that's 1 Google of monkeys. So we've got as many monkeys as it would be particles in the universe in 100 billion universes. Okay, that's the number of monkeys that are now typing. And so, how many characters will you get? You'll get something reasonable depending on what you're expecting. We got 66 characters, working on the 67. There's the 67. Okay, and so that's what it takes. That's what you get with a Google of monkeys. Now we can still do some other things. Let's try changing the number of keys per second. That second line there. So it says 1 key per second right now, and I can click the little plus on there and get the mouse down there, James. There we go. 10, 1,000, a million, a billion, a trillion. Okay, I went up to 1 trillion keys per second. Now we got a Google of monkeys, each typing a trillion keys per second. What will they type? You can see there, they type 70. No, I don't know if it started over again yet. It did it?
Yeah, it just did. So it's 75 characters.
Okay, 75 characters. You see what happens? It's exponential. in the backwards direction. We used to think of exponential numbers getting big. This is exponential getting smaller. So you don't get much, even when you add all kinds of monkeys. Okay, let's do one more thing now. Let's take the time. We got 1 second is a million years. 1 second is a billion years. 1 second is a trillion years. How many characters will we get? We get.
And this is the right order to get in the beginning, God created the heavens and the earth, Genesis 1:1, right?
That's right. That's right. Somewhere, some monkey is typing this by chance. And it's 88 characters. Some monkey we got 10.5 trillion years going by, 12, 13 trillion. And they're working on the O without form and void. Okay. And after multiple trillions of years, you'll get that O out of one of the monkeys somewhere.
Oh, my word.
Do you see just absurd.
This is showing the absolute absurdity of organizing things. Uh-oh.
Okay, here, now I'm going to just do a little explanation. So it's a good thing it's larger screen because I never would have read it down there. So that's great. Well, just how complicated would the first living thing be, the one from which other life supposedly evolved? Origin of life biologists have studied this question extensively and concluded that even after giving every benefit of doubt to the evolutionists, at least 124 proteins are absolutely necessary to any living organism. The simplest known living organism requires 600, typically, just to define those 124 proteins. Having an average of 400 amino acid molecules each would require the equivalent of about 124 times 400, the length of each gene, times 2/5, which is a conversion factor, and you get about 20,000 letters. Now remember, we did 87 there. Can you imagine trying to do 20,000 letters? Of course.
So we're trying to get 87 characters to get, or we're at 88 right now, 89 characters randomly, and we've gone through 100 trillion years at that speed. Yeah,
100 trillion years of a Google of monkeys. Okay, it's just absurd. You're never going to get to 20,000 letters, and of course,
you need 20,000 amino acids in the right order in order to get like just the basic stuff.
Right. Okay. Now I'll tell you something else. I wrote this back in 1988, before the Genome Project had been done, and that was the best guess I had at the time. 124 proteins, 124 genes, and we now know. We now have much better evidence, and that's what I'll bring up in the next part. It's not 124; it's 473 that we have found to be the simplest organism that we've been able to come up with so far. Okay. And so these numbers, that 20,000 letters actually gets increased to maybe 40 or 50,000 letters. And of course, you can't just take the DNA, throw it in water, and have life occur. It's a bazillion ring circus that all has to happen in orchestra. And you'll see that in the next section of this screen. Okay. Wow. So let me go back now I'll talk about J. Craig Venter. Okay, this guy is an amazing guy. These people we're talking about, Richard Dawkins, Stephen Hawking, and Craig Venter, they all are very, very intelligent people. And so, it's not a matter of intelligence. There are very intelligent people that are very deluded on the evolution question. And there are intelligent people that are on both sides of this. Okay, but Craig Venter, a pioneer in the work of sequencing the human genome, completed in 2000. In 2010, he created a cell hailed as synthetic life by a process called transfection. And they made up that word. What they're talking about is the fact that they took a living cell and they pulled the DNA out of it and then put in new DNA that they had manufactured, using what's the name of that program that
CRISPR.
They've got? CRISPR, yep. And so they generated a whole DNA string, and it wasn't little chromosomes, it was one big long string. And they injected that into the cell, and presto, they've got a new living cell that's never existed before. And on that gene, they've got the names of the scientists listed in there, and they've got a little, a code so that they can, that they can know whether it's genuine or not. So you can put anything in there they want, and it's just junk. The cell doesn't use it, but it makes the cell special. Okay, so after he had done that in 2010, he went on to attempt to identify the minimal gene set required to sustain life in the simplest cell. Now, we already knew that we had come up with a cell that lives in the reproductive tract of mammals, and it's about 525 genes long. And so he took that and then did what's called shotgunning. No, what do you call it? You kill a gene and see if the thing still lives. Oh, there's a name
Oh,
for it.
okay, yeah.
You know what I mean?
You're
And so
basically out of those 525 genes, you're eliminating one at a time and finding out
right,
if the cell still works. Okay.
right. And if it still works, fine. That's your new standard. If it doesn't, you go back to the original one and you forget about that gene. That's needed, and you go into a second one. Okay, and so you take out a second one, and so going through that process, he was able to take that 525 down to 473. Okay. So okay, I'm just going to keep on reading here. Of these, in 2016, announced the result of his team's work. He arrived at 473 as the minimal number of genes. Of these 473, 324 or 68% have known necessary functions. They're what process the DNA and the ribosome and all the different parts inside of life. Every form of life that we know of, funguses, everything has all of that machinery in there. The remaining 149 or 32% are a mystery. Their functions are unknown. And so now he's going to talk about that a little bit. Of the 149, okay, about 70 look familiar. In other words, they know what an ion pump looks like. Ion pumps lodge themselves in the cell membrane and move things through the cell membrane that need to be moved, because a cell membrane is kind of like a soap bubble, and things can't get in or out unless there's something there to allow it. And so these ion pumps sit in there and they allow things to come in, or they allow things to go out, and they're powered by the ATP, the energy cloning of the cell. But that's all super complicated. That's beyond what we're talking about here. Okay. The remaining 79, after you've talked about the ones that look familiar, are total mysteries and don't even look familiar. They have no idea what they do, but they know that when they take them out, the cell dies. And so listen to the way now that Craig Venter talks about this. And I kind of apologize. I'm taking very wholesale from an article on this because it's just really captions it very well. But here's what this article says, and you can see down at the bottom. I want to give him credit for that article. It's Robert Krulwich back in 2016. We built this world's simplest cell, but don't know how it works. Okay, and here's what he says. There are 79 genes in this group that no one has seen before. We don't know what they do, he's quoting Venter, and that's probably the most important finding, he told Science Friday. And it's frustrating. It's humbling. See, they thought they were right on top of it. In just a year or two, we're gonna make a cell from scratch. And here they can't even tell what 79 of these genes do, but they know that they're absolutely required for life to occur. When they began this project, Venter's team imagined that after years and years spent comparing human genomes, and realized it's now been decades, mouse genomes, fruit fly genomes, yeast genomes, and plant genomes, biology had a working script for what produces life. They thought they knew the basic parts, or most of them, but the truth is they didn't. Okay, let me see where my mouse is. There we go.
It's still a mystery. That's amazing.
Isn't this amazing? Continuing to quote, the scientific community has been basically suffering from the delusion that we did know all the biology, Venter says. We're truly like aliens from another planet trying to work out what these parts do. Even more humbling, these unknown genes have been doing what they do. Now, this is from their standpoint, been doing what they do for millions of years, or as biologists say, they've been conserved by evolution for some important reason. Now, I don't believe that. I know you don't believe that. God made these things 4,000 or 6,000 years ago, and they've been doing it for 6,000 years, which is amazing in itself. But
that just shows they like to call us God of the gaps. That quote right there shows they are evolutionists of the gaps. Somehow evolution, this blind, unintelligent thing, has a lot more intelligence than we have. They are evolutionists of the gap.
Yes. So it's very humorous. Now you notice 2016 has come and gone, and now, and it's been another 7 years. There hasn't been some major breakthrough. Now I'm not putting these people down. These are extremely intelligent people. What they're doing, wouldn't have a ghost of a chance of doing what they're doing. But there's a delusion that comes over them when it comes to it has to fit into the evolutionary framework. That's what you have to do, because the alternative is God. The alternative is a miracle. Something happened where a designer came in at the beginning, God, and set this all up from the beginning, and we've just been going downhill since then. Okay, reading
Wow.
on. So how could we not recognize them? How could the simplest life form ever be 1/3 unknown? Well, okay. There's something about the essence of life we've missed, thinks Venter. I don't think this is a God moment for him, but it certainly is a aha moment. Okay, perhaps he says life isn't built from independent parts like something in a machine shop. Maybe you can't take a bunch of well-known genes, clamp them together, each one doing its own thing. And then when you tighten the last screw, suddenly, shazam, a new creature sparks into being. Instead of focusing on genes, maybe we should consider the whole operating system, not the genes, but the genome, a functioning whole. Now, that doesn't speak well for evolution,
No.
because you've got to have everything there in a concert before anything happens, in a symphony. All right, well, let's go on a little bit here. Life may not be machine-like. We may be orchestral. Genes whisper, they amplify, they turn other genes on and off and make them louder and softer and even silent. They cause cascade effects, sending notes through the system that loop back, creating loops within loops. A living thing may be constantly changing melody, orchestrated by its constantly changing parts. For too long, Venter thinks, biologists concentrated on genes for this and genes for that. We can't just look at the function of a gene, he says. What those 79 mysterious genes may be doing, some of them anyway, is they may be pulling the parts together so they fit and compose and hum themselves into being. How do they do that? How they do that may take us a while to figure out, maybe a long while. Life, it seems, is darkly, richly complicated. And that's the end of the article. Is that
That's
something?
powerful. That
It
is
really
to have
is.
him say, look, we don't yet understand the most simple life forms.
Yes.
That's
Yes.
crazy. That's
Yes.
crazy.
Okay. Now I want to bring the Bible into this, because I think this is very interesting. Okay. We have in Romans chapter 1, verses 18 to 20, and many creationists quote this very often. But here's what it says: "For the wrath of God is revealed from heaven." And remember, this is a very harsh part in Romans 1. In fact, there's a guy in jail, a pastor who was put in jail for reading this on the radio. He's not allowed to read this on the radio. This is terrible stuff. So he went to jail for this. "For the wrath of God is revealed from heaven against all ungodliness and unrighteousness of men, who by their unrighteousness suppress the truth." Now, what this is saying is that the truth is not, it's not that they don't know the truth. They know the truth, but they're suppressing it. That's different
Yes.
than being ignorant of it. Okay. For what can be known about God is plain to them. And this means that them is everyone. Okay. This is
Yeah.
all humans. It's plain to them because God has shown it to them. Every time you go outside and you express wonder at something in God's nature, that's God speaking to you. When you're 3 years old and you pick up an acorn, you say, "Wow, how did this little acorn become that big oak tree?" That's a God moment. Yeah, that's a God moment. Now, the PhD scientist is going to come along and say, "Well, we know how an acorn turns into an oak tree, and they've got all these different things." No, they don't. And what actually happens? Well, let me go on with the quote here. Okay. "For his invisible attributes, namely his eternal power and divine nature, have been clearly perceived ever since the creation of the world in the things that have been made, so they are without excuse." And what I was going to say there is that this is kind of a theorem that we can get from Romans 1, is that the more we find out, the more we will find out that we don't know. Okay.
Yeah.
So back in the times of Darwin, he thought that a cell was just a bag of salts. There was not much to it. It was just a very simple little thing. And then we found out about DNA, and it's, DNA is digital. We were just learning about digital. DNA is digital. It's not analog anymore. And so that just threw everything. And all of this heredity stuff is coming out of that DNA. Slowly, the evolutionists just get to the point where that's no longer nothing that blows their mind. But that was just amazing. That was something and each time we find out more, it's more and more complicated. We thought we had it. That was called the dogma of evolution when we found out about DNA and how these four characters A, C, T, and G can be put into to make all these different letters and write books, for example. But then we found out about epigenetics. That word was escaping me. Epigenetics talks about different parts of the genome talking to each other in ways that we haven't even figured out, so that when a cell becomes specialized, like for instance a skin cell, it has to have just the right genes exposed so that it can do its job, which is different than a liver cell, which is different than a neuron, which is different than a blood cell, and so forth. There's about 200 different cells. And so there it is again. Where does all this come from? And every time we make a new discovery, we find that it's more complicated than we thought before. And think about the brain. Right now, we are learning how the brain works by putting it on machines that can tell the brain activity. That's kind of like learning about how New York works by flying over to 20,000 feet and watching the cars driving around on the roads. You learn some things. You learn that people go to work at 9 and get off at 5, and you could follow one car and see what it does, but you don't find out what's in the Library of Congress. You don't find out what's in the different museums and all the scientific things that are going on. But when we get down, the more we go in, the more complicated, and it turns out that we know less than of the total. We know less than we thought we did before, out of ignorance.
Wow.
So that's just wanted to point that out so that people can realize what God is doing here, and just be amazed, be in awe of what God is doing in his universe. Okay, and here's a few taking away pointers. Don't you be without excuse. When you look at nature, and I love to look at nature, remember where this is coming from, and don't just be blind to it. Okay. Also, don't be discouraged when you are unable to convince others to see what is plain to you, because you remember a time when you were deluded. There's kind of two different people out there. I think Dawkins is angry at God. He wants to destroy God, but there are many good Christian people who are old earth, and even that accept evolution entirely. Don't lose hope. We just got to keep hammering away. We just got to keep working, on them, and encouraging them to come to know the depth of what God has done in the first book and the first chapters of Genesis. Your commission from God is to proclaim the truth.
Amen.
And it's God's task to reveal truth to all who are willing to receive it.
Man. So Jim, if you had to summarize, Wesley was gone. He said he had to help a customer. So how long did it take the monkeys? So if we go back and summarize, could monkeys type Shakespeare? And that whole process, by the way, I did do some research, and let's see here. I found that, let me see here. Who was it that did it? Give me a second. Okay, so the idea of this could monkeys type works was actually originated from a French mathematician, Emile Borel, who pointed out in 1913 how unlikely it is that it would be for 1 million monkeys typing 10 hours a day would actually produce exactly the books, all the books of the world's library. And so he was using it against that process, and the evolutionists took it and said, it could happen. There's a chance. So what are how long would it take to get, we took, I forget how many monkeys and how many years to get, typing at 120,000 letters a second. And we got I don't even think we got 4 letters, right?
Yeah. I think we're working on the 5th. There's a humorous line in a movie that I cannot recommend, but this line is amazing, because this guy's after this girl. He's kind of a nerd or whatever, and he says, "What are the chances that I could get you to like me?" And she says, "Oh, 1 in a million." He says, "1 in a million? You mean there's a chance?" It's the same.
That's right.
So, that's the thing. And if you go and read that infinite monkeys theorem, basically it's saying that if you have an infinite number of monkeys, you would type all that there is to type an infinite number of times. There's no end to it because infinity is totally open-ended on the top.
Right.
So,
Wow.
all right.
Oh man, Jim, this is incredible. It sure puts, I don't know, how many nails can you put in the coffin of evolution? And they keep going, well, that's okay. That didn't do it. It's still possible. It could still happen. And you've just shown that, like, getting the amino acids, especially once you get to Craig Venture's work, getting the proteins, the amino acids to create not just one protein, 124 proteins, over 400 amino acids in the right order. It's like, it's not going to happen randomly. And just, if you're out there and you believe in evolution, social media, I know we let you stay on this week. Guys, it's impossible. It didn't happen. You are fearfully and wonderfully made. And I want you to read about that. And I want you to understand that. Matter of fact, I got a website that it's a gift from us to you, creationtoday.org/gift, G-I-F-T, creationtoday.org/gift. I want you to read that and understand who you are. You're made in the image of God. You're made special. You're made unique. And your Creator wants a relationship with you. And you really need to understand the truth of the gospel. Jim, this is incredibly impactful. The numbers don't lie. Evolution couldn't happen. Monkeys couldn't type Shakespeare. Oh, tell that story real quick. They actually did an experiment by putting typewriters in with monkeys. Tell them about that real quick.
It was in England. I think it was in the last decade. And they, as somebody as a PhD experiment, put a keyboard in with the macaque monkeys, and they typed mostly S's. They were just really amazed with that. And the leader of the monkeys came over and banged on it with a rock, and then kicked on it, defecated on it, urinated on it. They, everything they could possibly think of to do to it. But they didn't type out a Hamlet or anything like that. So yeah.
And they did publish what they did type, which was gibberish. Absolutely nothing.
Like 6 pages of S's mostly. So yeah. Oh yeah.
So you're telling me there's a chance? No, there's no chance whatsoever. Oh my goodness. Wow. Hey, social media, thank you guys for joining me. There's no way monkeys could type Shakespeare. There's no way evolution could have happened. We are incredibly designed. And that brings me to next week's show. Next week, I want to ask this question: does medical freedom include abortion? And I want to talk to one of the leaders, the pro-life doc himself. And I want us to understand the truth of what's going on. You are fearfully and wonderfully made. You are a very unique set of thoughts and personality and molecules that make you. And God didn't do that by accident. And He doesn't create any life by accident. It's a gift from God. Therefore, we should preserve and treat life as valuable. We'll be talking about that next week as we answer the question, does medical freedom include abortion? I hope you'll join me. To my partners here, thank you guys for hanging out. I sure do appreciate you. I'll let you stay on as we do a kind of a behind the scenes here with Jim and ask him a few more questions. To my social media, I'll let you guys go. God bless you. I'll see you next week.
That computer, having run all those things, it started really, I'm having a problem with my computer. Couple of things I wanted to show, since the people are here. I've got this DNA that this DNA is the code for collagen, and the collagen gene is about 5,000 characters long. So these each about a 1/4 of an inch long, and so I've got the whole thing. This is the actual code. I actually, this is correct, written in A, C, C's, and G's, and it's 100 feet long of code for the collagen. Okay, so that's what it produces.